Hey everyone, welcome to this second episode of the video series that I've very insipidly and uncreatively called Textbook to Code, where I take software engineering and computer science principles from textbooks and convert them to code and expand on them and try and make sense of them in as much detail as I can manage. And the book I've picked for this, well, I guess for the start of this series is Effective Java by Joshua Bloch. Certainly the best programming book I've read so far. And the book's got, I believe, 90 items, and we're still on item 2. So I'm sure it's going to take me a long time to get through the whole book. But that's what's exciting about this, because I feel like one item leads to another item, and that item leads to another item, and that'll point to some design pattern, that'll point to some concept in Java or computer science in general, and I find that really interesting. And really, I hope a lot of programming books, and especially well written the way this book is written by Joshua Bloch. Saying that though, as per usual, as I did do in the previous episode, I want to make a few caveats or have a bit of a proviso. So if you did watch the previous episode, you can skip this bit because I'll pretty much be repeating the same thing for any new viewers. The first point, of course, is this is not a tutorial. So unlike many programming videos on YouTube, I certainly don't want this to be a tutorial. I'm not a teacher, definitely not an expert, and I'm not trying to tell you how something is done. Really, what I'm doing is collectively trying to make sense of certain concepts in this book and trying to understand them. It really, in many ways, is a selfish pursuit in that sense because I'm not trying to teach anyone. I'm just trying to make sense of it, and along the way, if you get value from it, fantastic. That's at least what I hope. Frankly, I like to think of it as blind leading the blind. But in this case, really, I'm not leading, but I guess because you're watching this video, in some sense, I am. But I am as blind and ignorant as you are. This is simply a exploratory disquisition. That's it. And I think what I want this to be is similar to what we would do when if you've done a computer science or software engineering degree in a university tutorial where you get together. There is a tutor, of course, but generally what happens is you get together with your mates, with your the other students, and try and make sense of some assignment problem or some programming problem. And I think there's great learning that happens in that kind of collaborative, collective thinking. And needless to say, but I have to say it because this is a proviso after all, I will inevitably make mistakes. So please point them out, leave them down in the comment section below. Of course, for my own learning, but especially because I don't want to mislead anyone. And I think that's why in every single video, even though it's going to get a bit repetitive, I am going to have this bit where I do say, please don't think of this as a tutorial. I don't think I'm in a place to teach anyone programming at the moment. And on the note of programming, of course, this is a programming video, so it only makes sense to have all the code that I use on GitHub. Not only my code, but I'll also link all the code that Joshua Bloch has published on his personal GitHub repository for item 2 of Effective Java. So on that note, without further ado, let's get started. The second item states, consider a builder method when faced with many constructor parameters. Personally, I found it much easier to understand this item than the previous one. It made a lot more sense, probably because I have faced this problem day to day working in my team, where there's mostly a utility class with a whole bunch of parameters for constructors. And it can be a real pain to manage, and even using it as a client can be quite chaotic at times and quite a mess. So he states, static factories and constructors share a limitation. They do not scale well to a large number of optional parameters. So of course, I don't think I need to go into detail on what optional parameters mean. The term itself is self-explanatory. And over here, though, this example kind of demonstrates that, even though what we've done here is use the telescope constructor pattern, which Joshua Bloch says is a bad idea, that it probably shouldn't be used, even though this is what traditionally programmers have used. And in fact, in the code base that I'm working on right now in my current company, I believe this is what we've done. Oh, Well, I think we did this in a previous version, but we did change it up. So that's really good. And this is what this really does. Is, as you can see here, I have two instances of the nutrition facts class, which is this class here. It's got a bunch of privately defined member variables, and this is the bit that sort of implements the telescope constructor, but I'll get to that a bit later. The idea being both these instances, Koch and Bundaberg, they've got different number of parameters have been passed into it because, of course, some are optional. In fact, I think most are optional. And depending on how you want to build it, how you want to construct your object, you can define it. So now let's go to the bit where Joshua Bloch says, traditionally, as I did say before, programmers have used the telescoping constructor pattern, in which you provide a constructor with only the required parameters, another with a single optional parameter, a third with two optional parameters, and so on, culminating in a constructor with all the optional parameters. So these two objects, Koch and Bundaberg, which both are instances of the nutrition facts class, the Koch object is pretty much using all the parameters. It's using this constructor here. This constructor here. And then the Bundaberg object, which is just using only three optional parameters we've set, which uses this constructor here. Regardless, you probably can see what I'm doing here. We've passed a lot of zeros. It's unnecessary. And even on the client side, or on the client that's using this constructor, has just passed zeros sometimes when for the value fat. And it's not that complicated. If you look at the code base, you can see that it's very verbose. Just the constructors itself in the beginning of a class, you got God knows how many. I mean, here there are only 6 parameters, but imagine if it's a class with 20, 30 member variables or whatever you wanna set when constructing that class, constructing that object. Sorry. And as Joshua Bloch says, in short, the telescoping constructor pattern works. Of course it does, but it is hard to write client code when there are many parameters and harder still to read. He also states, and this is kind of funny, I recently tweeted that I like to call myself a programmer, but IntelliJ writes most of my code for me, so I don't really do anything anymore other than just using autofill and IntelliJ kind of taking care of everything else. The modern IDEs are so good that this problem doesn't really apply anymore, I think, because he says here, if the client accidentally reverses 2 such parameters, the compiler won't complain, but the program will misbehave at runtime. So what he means here is, you probably can see, let's take this second object, Bundaberg, Bundaberg object. And what we need to pass as the first parameter is the serving size, and then it'll get set properly in the class member. And then there's servings and calories. So let's say you set the serving size as 2 and servings as 360. That is wrong, but the compiler won't complain. The error will only come up at runtime. Maybe the QA team will pick it up, or some unit test. Who knows? But of course, with IntelliJ or most modern IDEs, that problem won't be an issue, because when the client is using that constructor, it does exactly say what you're supposed to pass. So it's pretty clear and explicit, but nevertheless, that's one downside of it, and we shouldn't always rely on IDEs. The negative, of course, is the problem with scaling and also just passing these useless zeros into constructors. So, and it's fair to say, arguably, the telescope constructor is an anti-pattern, where a class has multiple constructors with different signatures, varying parameters in particular. And I believe if you do just Google the word constructor pattern, there'll be a lot of blog posts regarding why it is an anti-pattern. Look at this. Just the top searches are regarding alternatives to the telescope constructor pattern, it being an anti-pattern, whatnot. And even this video here saying avoid telescoping constructors with builder pattern. Makes sense. Probably a lot of these blog posts were inspired by Joshua Bloch himself. That moves us to something probably a bit better than the telescope constructor pattern, the Java Beans pattern. In this pattern, you call a parameterless constructor to create the object, and then call setter methods to set each required parameter and each optional parameter of interest. So let's see what that means. But before we get to that, I just realized I should expound on these 2 points. It'll just make things a bit more easier. Now, Java Beans, what is Java Beans? We hear this term everywhere if you're a Java developer. All it is a standard. It gives a class an empty constructor with getters and setters, a public argumentless constructor, and it's also serializable. Even though this is what a Java Beans is, the Java Beans pattern still isn't the most apt pattern to use when faced with many constructors. And as Joshua Bloch, I'm going to start calling him JB. It's just easier because Joshua Bloch is a mouthful. So as JB himself states, the Java Beans pattern has serious disadvantages. So I did read out the definition of what this pattern is before. This is really much easier to even understand conceptually than the telescoping constructor pattern. Clearly what you're doing here, so we've got another class. We've got a class called Nutrition Facts JB. Why did I call it JB? I don't know why it's... Oh, of course, because it's Java Beans. I wanted to call it JB just to differentiate it, I guess. And we've defined the empty public constructor here. And that allows us to create a Coca-Cola object of this from this class. And simply using the setters, I've set all the values. So whatever the members are, serving size, calories, whatnot. And yeah, it's as simple as that. That's what it does. However, as I said before, this is not a good pattern to use when one is given a class with a lot of constructor parameters. Firstly, of course, practically speaking, as you can see, it's a bit verbose. It's just to create this object, you got to do all these things and use setters and set the values. Kind of annoying. And the second one, and this is an interesting one, I'm going to first read out the paragraph and explain what JB means by this. The class does not have the option of enforcing consistency merely by checking the validity of the constructor parameters. Attempting to use an object when it's in an inconsistent state may cause failures that are far removed from the code containing the bug, and hence difficult to debug. A related disadvantage is that Java Beans pattern precludes the possibility of making a class immutable and requires added effort on the part of the programmer to ensure thread safety. What that really means is this. There are all these terms. Some of these terms are a bit technical, but I'm quite sure, I'm not a senior Java programmer who's been coding for years and years. I've only really been coding for two or 3 years, but I've still seen things like this day to day at work. So over here, you initially construct the Coca-Cola object with the empty constructor. And then you say, you set the value using a setter, set serving, whatever. And then you say, set servings, whatever, set calories, whatever. And then let's say, while this object is in the process of being constructed, it's in a certain state, someone decides to do some computation here using this object. So decides to do some computation using this object, Coca-Cola. Now, this can give us a lot of problems because the class doesn't mandate for the object to have a consistent state when it's being created. Because let's say when this computation takes place, these two values, set sodium and set carbohydrate, are necessary. And most of these errors will only be code runtime. It cannot be code compile time. Clearly, it cannot be code compile time because if I just go and, let's say, do something here, system.out, I'm just going to print this out. I know it's really not a computation, but it doesn't throw any errors here. The ID doesn't indicate that, oh, this object is in an inconsistent state. And this is in my opinion, when I did understand what this is, I think it can be a serious disadvantage, especially in large enterprise level systems, which is mostly what Java is used for, in like distributed systems. And yes, just to reiterate the point JB makes, attempting to use an object when it's in an inconsistent state. So let's just assume, for all intents and purposes, at this level, this Coca-Cola object is in an inconsistent state. We don't want it to be in that state and be used by a client. May cause failures that are far removed from the code containing the bug and hence difficult to debug. Again, it makes sense because they're runtime errors, and we all know that runtime errors are quite difficult. to debug. And in my notes, I've stated here with a bit more brevity compared to the long-winded way I explained it, splitting the construction to multiple parts may put the Java bean in an inconsistent state. So clearly the construction is being split into multiple parts, and there's a high possibility that it could be in such an inconsistent state. Which is why JB proposes using the builder pattern. Now, what is the builder pattern? So let's try to understand. Firstly, there's a quote that I've got here by the great book, from the great book, Design Patterns by the Gang of Four. I haven't read that book yet. I own a copy, I refer to it, but I'm really hoping to do a similar video with that book too. I'll probably do this book first, the Head First Design Patterns, and then I'll see if it's worth doing one on that book too. I'm just gonna do it. I'm just gonna do it because I want to, because I'm a fan. I'm a connoisseur of great programming books. So here's what the Gang of Four states. What the builder pattern does is separate the construction of a complex object from its representation so that the same construction process can create different representations. Okay, what in the world does that mean? Let's take a look at another way the nutrition facts class was constructed, but in this case, using the builder pattern. On the client side, using the builder pattern on the nutrition facts class, constructing the objects using that pattern, it's done beautifully. It helps us to circumvent some of the disadvantages that we discussed earlier with the previous patterns. But saying that though, of course, it's a bit harder to understand as to how it works. The first thing to keep in mind is there's an inner public static class called builder. So there's a separate builder class in the nutrition facts class. And when we do construct this object, there's no way of constructing it without using this builder class, the inner builder class. Let's try and go through this line by line. I think that's the best way to understand this. When we do construct this object, we don't directly use the nutrition facts class. We instead make the desired object using this inner builder class. And of course, because it's static, you could just access it as it belongs to the nutrition facts class itself. You could access it directly, I mean. So simply put, the way the client really constructs this object is using the builder object. And the builder object has some setup methods. How does that work? So let's take a look at this. It's got nutrition facts builder, and of course, there are some parameters that are mandatory. You need them to even construct this object. And those two are in this builder classes, serving size and servings. So that would be defined here. When we do the constructor for the builder class, have these two values as being mandatory. And afterwards, of course, it allows us to simply set the other values as per our requirements, as per the client's requirements. So for Coca-Cola, we've set the calories. The calories are right here. And then we've set, oh, there's another thing I want to add here. Do we get to that a bit later? Oh, sorry. There's a bit here about invalid parameters. We shall get to that a bit later. So we are adding the calories, and then we're adding the sodium, carbohydrate, whatever. And those stuff are being passed on to the private constructor, the private constructor of the nutrition facts class. And it's being accessed through this builder object. And then afterwards, when the client is done using, or the client is done constructing the Coca-Cola object, you simply use the build method and build the object. Quite straightforward if you think about it. And even practically or conceptually, this makes a lot more sense. And yeah, I should mention this. The client calls a parameterless build method, which I did mention, to generate the object, which is typically immutable. And now I want to get to that bit that I said I'll discuss a bit later previously. It's this idea about having valid parameters. Here's a good example of this. In the builder class, so the only role for the builder class is to really build objects. Therefore, in all these methods, one could do checks for invalid parameters and throw illegal argument exceptions. If for instance, when building this object, someone passes a parameter or an argument which is of illegal type or if it's of if illegal quality. I'm just looking for the word here. Doesn't matter. Sometimes, sorry, it's been a long day. My brain's everywhere. Here's an example of this. So calories. Of course, anything can't really have negative calories. At least that's what we're told, and I think that's true. So over here, initially I've passed the calories to be 100 when constructing this object, and I'm doing a check on the calories method, which is here in this method, whether the value is the value should be greater than 0 for me to set it into the calories member variable. If not, I'll throw a illegal argument exception. So if I go and do -8, and then if I try to run it, there we go. At runtime, it'll say, it's negative. You can't have negative calories. What are you, crazy? What are you trying to sell? One of those fit tees on Instagram? I'm just trying to make a joke and be funny, but that was just a terrible joke. Pathetic. So Joshua Bloch says, to detect invalid parameters as soon as possible, check parameter validity in the builder's constructor, and methods. So that's what I've done here pretty much. Check invariants involving multiple parameters. So this is again, I'm checking this parameter here. Do the checks on object fields after copying parameters from the builder. If a check fails, throw an illegal argument exception whose detailed message indicates which parameters are invalid. That's actually a good point, because it even tells us specifically here where it's failing. So we know debugging is much easier. That's the best way of putting it, because if you do recall, with the previous two patterns, a big issue is even if something fails on runtime, the debugging can be a lot more harder and much more deeper in the code. That is not going to make programming easy. And of course, if I didn't already state before, the code is a lot more neater. It looks prettier. You could use method chaining, keeps the code concise, and very importantly, we don't run into that problem of having objects in inconsistent states like we would do with the Java Beans pattern, because that doesn't allow it here, because you need to chain all the methods when constructing the object. And certainly method chaining is something we see a lot in different JDK libraries. It's most probably because they've used the builder pattern, which is why for us using them, it's a lot more easier. And then JB states, the builder pattern is well suited to class hierarchies. Use a parallel hierarchy of builders, each nested in the corresponding class. Abstract classes can have abstract builders. Concrete classes can have concrete builders. This was a bit hard for me to get. I wouldn't say it was hard for me to get, but there's one certain part, which I'll get to a bit later, involving generics, which I had to really struggle to get my head around it. But once again, though, it does once it does make sense, once it clicks, you can see the beauty of the builder pattern in it, and that's the best part about it. So let's try to understand what he means by the builder pattern is well suited to class hierarchies. Firstly, I'll simply define or explain this class hierarchy I've built here. We have a simple abstract pizza class, which I've defined here, as you can see, and then we have two subclasses that inherits this class. We have calzone, which is a concrete class that extends the abstract pizza class, and then we have New York pizza, which is also another concrete class which extends the abstract pizza class. And afterwards, if you do go to the client, you could see how it's been implemented. And again, I know this is very high level, but I'll go into the details soon. Similar pattern. If you do run it, you'll see both these objects have been created. And I'm getting the superclass. It's both got the same pizza superclass. Makes sense. Similar pattern, ending with the build method. So firstly, let's take a look at the pizza class, the pizza abstract class, and see what's going on here. In the similar way, because we're using the builder pattern, we have another inner static builder class. But you probably see it's a bit more different. We need to allow something called a simulated self-type. Now, this was the bit that took me a bit to grok and make sense of, because it involves using generics, and it's doing something called a simulated self-type. What does that mean? Let me see if I could explain it. I would say I got it, but I think I'm still struggling to articulate it clearly. And let me give it a shot. So I didn't get what a simulated self-type was from effective Java. I couldn't understand it. And then I found this great blog post by this gentleman's name is Nikolai Bloch. Fantastic article. It was written in 2016. Pretty much goes into everything you need to know about the idea of Java not having a self method, or it doesn't allow us self and this. Those two keywords are a bit different. I'll get to that too. Because Java doesn't have that, we sort of have to simulate it, and that's what Joshua Bloch is doing in this example, but also what one would generally do to get a self-type. And it's important to understand, if we didn't do the simulated self-type, we may have to use casting, and that is not going to work, because it's very important to understand that for the builder pattern to work with the method chaining, which I have, where's an example? Nope. It's always when you need an example. Oh yeah. Nope, that's not the that's telescope constructor. Yeah. For this method chaining to happen, the proper type or the proper subtype has to be passed. Has to be returned. And in the hierarchical, this is a bad example. I should be using the hierarchical builders one. Yes, over here in the class hierarchies, the proper subtype has to be returned for this method chaining to work. So what a simulated self-type does is these subclasses, so in this instance it's New York Pizza and Calzone, they can get an instance of their own type instead of the parent. And again, I know I'm sort of beating on a dead horse here, but it's important to understand that for this method chaining to work, they have to get a instance of their own type, not the parent, not the abstract class pizza. New York Pizza has to get an instance of New York Pizza or of type, of subtype New York Pizza. And before I do a deep dive in the code, I want to read these excerpts from Nikolai Bloch's blog post. The reason being, again, I think it's important to first conceptually understand what a simulated self-type is, what's the reason for it, and its justifications, let's say. So Nikolai states, a self-type refers to the type on which a method is called, more formally the receiver. But Java doesn't have this feature. So in here, the self-type would be, why do I keep losing that class or that bit of code? Bloody annoying. Where is it? There we go. You son of a bitch. So here, this in the method chaining, on which method is called, more formally called the receiver. A self-type, so the receiver should get New York Pizza type. But Java, unfortunately, it doesn't have this particular feature of a self-type. If a self-type is used in an inherited method, it represents a different type in each class that declares or inherits that method, namely that specific class, no matter whether it declared or inherited the method. Casually speaking, it is the compile time equivalent of this.get class, or the type of this. I think that's quite straightforward, but it probably will be quite straightforward once we look into the code base. Let's start off with the abstract class. It kind of makes sense because the subclasses are going to inherit this. So we have this pizza constructor method here. Oh, I want to state one thing. I will not go into detail on this bit, but because we'll be discussing it in a future video in item 50 to be specific. But the idea is that over here in line number 33, we're making what one would call a defensive copy. This is just to ensure that the encapsulation of this class isn't broken, that fundamental OOP principle isn't infringed upon. We stick to our principles, so us OOP programmers. So what this does is when the native class changes a mutable object's field, a defensive copy should be made anytime it's passed into a constructor like this or out of the class. When the object of this class will be created, this topics member is what's going to change. It's going to be mutable, because in the add topics method, it's being changed essentially, and that's why we create this defensive copy. Again, I'm not going to go into detail. Firstly, because I think this is a bad example to understand it. It even took me a while. I had to go through some blog posts, but also because we will be discussing that in the future. And when we do get to item 50, which probably is going to be next year, I shall leave a link to that video in the description too. In any case, I don't want to go off on a tangent because I want to focus on the simulated self-type. So pizza.builder is a generic type. That would be here when we do construct the builder object. It's a generic type with a recursive type parameter. That's the confusing bit because, it's called a recursive type parameter because, as you can see, pizza.builder is extending the builder with its own generic type parameter. And I've even left a comment here saying that the generic type parameter here is necessary for method chaining to work. And same comment I've left here. It allows to simulate the self-type. And Joshua Bloch says this along with the abstract self method, that would be this. And this will be overridden by the subclasses because it's, in fact, this is probably a bit more easy to understand because it's called self, sort of makes sense. This is what gives the subclass an instance of their own type instead of the parent, instead of pizza. So New York Pizza would get an instance of their own type instead of the pizza type. However, in combination with this bit here, the recursive, the simulated, the recursive self parameter. This is really annoying because it's really hard to get your head around it. And this abstract self method, it allows us for method chaining to work, and this is the key point, without the need for casts. You probably remember I showed an example before, which was this. So let's assume this extends some superclass called superperson. And here, when this does return it, it shouldn't, if you don't put the cast, it will return a type of superperson, not person, and which is why the cast is required here. However, in our case, when we're using the builder pattern, because of this abstract self method, we don't have to do that. We don't have to use the casts. And I shall show you now in a subclass. So let's use New York Pizza where this happens. Firstly, we pass the proper subtype of this class to the generic parameter. That's for sure. And then we have this bit here where the overriding takes place of the self method, where it returns an instance of the subclass of New York Pizza and not pizza. And in that way, as we do use the method training, and finally the build method returns the correct subclass. It will not, it's clearly over here, it's saying return New York Pizza of this instance. So this is what allows it all to beautifully come together when we do use it over here with the method chain. I don't know how well of a job I did at explaining that. It is a difficult concept to grasp, especially the recursive type parameter. I still am struggling to understand that really, if I'm being honest, but maybe in the future videos I should consider coming up with myriad examples, not just this particular example, but trying to even create, because this some of this code I got from Joshua Bloch's GitHub repository, well, most of it in fact. So I should probably try and create some examples on my own, which will make it easier for me to expound on. In any case, JB states, this technique, it's sort of funny. Sometimes I refer to him as JB, sometimes as Joshua Bloch. What am I doing? The perpetual contradictions. I'm just going to stick to Joshua Bloch. I changed my mind. Joshua Bloch sounds better. He's got a beautiful name. What can I say? This technique, wherein a subclass method is declared to return a subtype of the return type declared in the superclass, is known as covariant return typing. It allows clients to use their builders without the need for casting. Covariant return typing, to be honest, isn't that hard to understand. And what we're really doing here is covariant return typing by getting uh, a subtype of the return type. So if you go to simply, if you go here, I have two classes. I have the class, I created two classes. Oh, also, thanks to this Stack Overflow user who helped me understand this. The person's name is, the person also gets into something called contravariance, but we shall not get into that because it's not that apt to Java. However, it's just an interesting engineering or programming concept to understand. This user hard coded. Thanks to this user on Stack Overflow, I shall leave a link to the answer down below in the comment section. Sorry, in the description. So here's simply what covariant. What was it? Covariant return typing is. We have a class called author, and this author has this method. So it's got a private member field called name, and then of type object, and then we have another method called get author name. Simple as that. And then we have another subclass, Dostoevsky, my favorite author, who extends the superclass author. And here we're setting another private member variable with the name Fyodor Dostoevsky. And here we are returning a subtype because string is a subtype of object of the object class. Because think about it, this is covariance because while it does return a subclass of the return type, which is again object and string as I described before, it still fulfills the contract of author.getAuthorName. This contract here is fulfilled. This is what covariance is. And the same concept, of course, applies in the hierarchical classes with the builder pattern, because this returns a subtype of, New York Pizza, let's say, that class returns a subtype. It is a subtype of pizza, and it does fulfill that contract down the method chaining, if that makes sense. And to conclude, Joshua Bloch states, a minor advantage of builders over constructors is that builders can have multiple var parameters because each parameter is specified in its own method. Makes sense. I think New York Pizza, pizza test probably isn't the best example, but a good example would be the nutrition facts class. We can have as many constructors as we want because all these constructors get their own method. And he continues, alternatively, builders can aggregate the parameters passed into multiple calls to a method in a single field, as demonstrated in the add toppings method earlier. So this add toppings method, as you can see, we're passing multiple parameters into the add toppings method, or more accurately, making multiple calls, and this builder class is aggregating it. He continues, a single builder can be used repeatedly to build multiple objects, of course. So examples here, pizza, calzone, different objects being constructed in different ways using the same builder class. The parameters of the builder can be tweaked between invocations of the build method to vary the objects that are created. These parameters can be changed as we require, depending on how we write the different methods in the builder class. A builder can fill in some fields automatically upon object creation, such as serial number, that increases each time an object is created. This is a very astute point. I think a good example of that would be similar to the idea of, checking what the proper arguments passed are and doing type checks and different validations on a method. Because these are methods, a lot can be done within the builder class. So if I try to go back to the previous example where I was checking for the proper argument, the way we've done this check in calories, we could even have something which automatically adds a certain value or changes an object automatically depending on the way it's called. And it could all be done simply because it's a method. And of course, like all great programming and engineering books, in Effective Java, Joshua Bloch does discuss the trade-offs. He explicitly states the disadvantages of using the builder pattern for this instance. And one of them is something I already discussed. It's certainly a bit hard to understand. One has to get their head around it, especially with the simulated self-typing and whatnot, and understanding how the inner class works within the bigger class. and that can be a bit more verbose and certainly a bit harder to grasp initially. And then he also says that if you start out with obsolete constructors and static factories, and then move the code base to a builder pattern, which I think is what happens most of the time. So this second point, the first point is it's a matter of practice. The more you use it, I believe, the more one will become more attuned to using the builder pattern. But the second one is definitely a trade-off worth considering, because generally what would happen is we would not use a builder pattern in a large code base, and then we would want to use it as the number of parameters increases. And then making that shift can be quite hard. So if it's a greenfield project and if you're starting from scratch, always better to start with the builder pattern, even if one has a small number of parameters for a certain class. That's it. That is the second item of Effective Java by Joshua Bloch. I sincerely do hope that you got some kind of value out of this, and I really am trying to get better at making these videos and really expounding on these points. It is a bit hard because firstly, I don't think programming and computational thinking naturally comes to me. I need to really struggle with the problem a lot for it to make sense. And I think that's most people really. So this isn't like false modesty or whatever. I think it's normal for most people. And I did realize, for instance, the part where I was going through the simulated self-type, that was a bit harder to understand. But on that note, I want to thank you for watching this video. Next item is going to be, and I have already started writing the script for it and, putting the code base together. The item 3 is enforce the singleton property with a private constructor or an enum type. This item is a bit easier to understand than the previous two. I can assure you that. In any case, thank you for watching. I do appreciate it. I appreciate you allowing me to ramble and go on. It's good. Cheers. See you in the next one.